Hello, my name is Tenuta. I'm a professor of soil science in the Department of Soil Science at the University of Manitoba, and I'm here to talk to you about soils today. Soils is one of those things that we take for granted almost every day in our life. It's very important for sustaining our life and for sustaining the environment around us. So let's just take a look at soil below our feet. This is the soil here, the Newdale soil, which is the provincial soil of Manitoba. Yes, a lot of provinces in Canada have a provincial soil. So just like they have a tree and flower, they also have a soil, which tells you something about the importance of soil in our lives. The first thing you notice when you look at a soil profile like this is near the surface of the soil is this dark black color. This was not here originally when the soil material was first deposited, okay? It would have looked more like this down at the bottom, which we call the sea horizon. You can see it's pale in color. This is just the particles as they were deposited perhaps thousands of years ago, okay? It's just sand, silt, and clay particles together. And as we move up in the profile, now we have the effect of life, particularly of plants and plants interacting with bacteria and fungi and other soil organisms. We have the B horizon in the middle here, which you can see the color is different than down in the C horizon. It's grayer, starting to become darker. And as we get to the surface, it's very dark. And this is because roots, leaves, and stems have decomposed. Bacteria and fungi have done that decomposition. And new material has been formed called humus, which is black. Hence, you can think of soil as living or the product of life. Okay? And this black material is very important for so many reasons in helping shape the characters of soil. That original material deposited would have been of three primary particles: sand, silt, and clay. Now they vary in size, with the clays being the smallest in size, being about 1/100th of the width of a strand of hair. The largest particles would be sand, and they could be as big as about 2 millimeters in diameter. And intermediate are silt particles. Now we can characterize soil based on the components of the sand, silt, and clay present in it. And we call that the texture of soil. And we have a soil texture triangle as a representation of different classes of texture, where we have clay, silt, and sand on different edges of the triangles, with increasing contents of clay, increasing contents of silt, increasing contents of sand. So for example, a soil that would be about 80% clay, 10% silt, and sand would be positioned in here in the red area near clay. And a soil that would be predominantly silt with a little bit of sand and a little bit of clay would be down here, for example, in this orange area called a silt loam soil. Now these different classes of textures of soil have different properties that they impart on soils. For example, a clay soil can be problematic for water to drain through that soil. A sand soil, on the other hand, can be problematic in not being able to hold enough water in it, okay? And then we have soil textures such as a loam, which is a mixture of the three in almost equal percentages, which forms the basis to produce a really great soil in terms of having these particles bind to each other and to allow water drainage, but also water retention. Now, these three particles interact with this humus material produced from the organic matter as it decomposes, okay, to create what we refer to as soil structure. Soil structure now is the aggregation, the production of units of sand, silt, and clay with organic matter, okay? And the aggregates that are formed can be range from anywhere from 1/10 of a millimeter in diameter all the way up to 5 millimeters in diameter. So if you take a shovel of soil, you lift it out of the ground, and the soil kind of crumbles in front of you, chances are that's because of the soil structure has been created by organic matter interacting with these three primary particles, okay? So this humus material here is excellent for creating soil structure, but it also has nutrients in it, particularly nitrogen and phosphorus. And the nitrogen phosphorus in this humus material is not locked up forever in there, but however can be released slowly as bacteria and fungi continue to degrade this humus material, releasing the nitrogen and phosphorus for plants to be able to take it up. Now, it's not just all about fungi and bacteria in soil. There are other really important soil organisms present, such as protozoa, nematodes, mites, earthworms, springtails. These all work to help release nutrients from fungi and bacteria that would be locked in their bodies because they feed upon, prey upon the bacteria and fungi, killing them, consuming them, and then releasing the nutrients from their bodies. So in all, when we look at soil, it has many benefits to us, and particularly soil that is healthy with lots of organic matter in it and a healthy soil life, because that soil becomes a reservoir for soil nutrients to be made available to plants. It can help store water and aerate the soil for good plant performance. It can also tie up toxins and contaminants because the humus has an ability to lock them up and keep them away from plants and from the food chain. Other thing is that this dark material contains carbon. So it's a means to store CO2 from the atmosphere and sequester it in soil as soil organic matter. So I hope that through this you have a better appreciation for soils, and the next time you walk on soil, you'll appreciate its beauty and also its great benefit to us. So thank you very much.